Hi, everybody. Welcome to Tree Stuff's Lunch and Learn for today. My name is Gavin McWilliams. I'm with Samson Rope. We are very, very excited to be here. We're very excited to have you join us, and we'd like to thank all the people at Tree Stuff for having us here as well. These guys have been really great partners with us for the last several years. So again, really, really excited. And just for your information, all upcoming events can be found on treestuff.com/events. So I want to take you through a few of the things we'll be talking about today. First of all, a brief overview of Samson Rope as a company. I've got a special guest that we'll talk to about engineering and testing. I'll take you through some of the new product that's coming out and take a walk through some of our online resources for you. So first of all, about Samson Rope. Everyone is probably very, very familiar with the lion and Samson itself. The trademark was registered in about 1886 or so, and it is the longest in-use, continuously in-use logo in North America. So that's about 140 years. That beats out Coke. That beats out, I don't even know who, Apple's relatively new. But so we've got a pretty good history behind us, and we're based on innovation. We'll talk about that a little bit later. But first, a little bit about where we are and where we sit. Way back in the late 1800s, the company started about an hour outside of Boston by an MIT grad, and eventually moved over to north of Seattle. We're actually in Ferndale, but we consider ourselves part of the Seattle larger urban area. And we also have a manufacturing plant in Louisiana, in Lafayette. So some of the things about us, we're very much Seahawks fans. The loss yesterday, of course, pained most people here. You know how it goes. The Mariners will never make the postseason, and we're aware of that as well, but we enjoy getting to games. But locally, there's lots of hiking, there's lots of sailing, mountain biking, and all these things either attract people or keep people here. So that's one good thing we have going for us. Fantastic skiing, snowboarding, splitboarding, you name it, and really, really great windsurfing and canoeing. So again, really, really solid, really happy. So again, back to the company itself. We're about 140 years old or so, and we're based on innovation. In fact, Samson developed the first 3-strand rope back in the early 1900s before anyone else did. So what that ultimately does is just grow the overall strength of the product. Later on in the 1950s, Samson was the first to develop the first double braid rope, which is the construction that you guys will see most anything else coming up. We helped support the space shuttle and all the other NASA space missions that have come over in the last 40, 50 years or so. And our flagship product is AMSTO Blue. So back in the 1980s, we came out with the first high modulus polyethylene rope, which is essentially a chemically coated rope, 12-strand rope product that is as strong as steel, but about 1/10 of the weight. So you can see product that is about, I don't know, it's about 6 to 7 inches in diameter or more, and can pull a tractor. There are about 52 or so diameters of AMSTO Blue, but it's pretty impressive. So yeah. And we cover lots of markets in the area. We cover recreational marine for sailing. Obviously, we do lots of arborists. We do rescue and access, commercial fishing, as well as our workboat, tugboat, and then our utility and mining markets. So we've got our hands in lots of different markets for lots of different applications and can provide lots of different solutions. So again, we're pretty pleased about that. So for our special guest, I want to hand you over to our technical director of R&D, Danielle Stenvers, who's got some interesting things about how we test, how we stand on quality, and a few fun videos that she's going to take you through. So I'll hand it over to Danielle. Thanks.
Good afternoon, everybody. So as Gavin said, my name is Danielle Stenvers. I'm the technical director here at Samson. I've been here over 20 years, and personally, I think it's a pretty fun job. I get to do lots of new design and development and playing with test machines. So with that, sorry. So new product development might mean a new rope design, or it might mean using existing products and combining them in different configurations, using them with new hardware, and creating assemblies. For new product development, it begins with the engineering group here. We've got a pretty diverse group. Scientists and engineers, backgrounds in chemistry, materials, mechanical engineers. Now, there's only so many rope constructions out there. So what we really do is try and focus on the fibers, the coatings, the combination thereof, the manufacturing processes, and all those things come into play to kind of put together the end product and the performance that you're going to get out of the rope. But we don't do it alone. We work pretty closely with fiber manufacturers and our suppliers. We work with customers. We send things out into the field for trial. And we also rely on people like you, industry experts. We need your feedback. How does this work? Does it not work? What do you like about it? And even fun things like cosmetic colors. You know, what color works the best? What can you see in the trees? So all of that kind of comes into play. So we're not doing it alone, sitting in a back room, dreaming up crazy stuff. We do that too sometimes, but we need your input. So beyond just the product development, we have an application engineering group, and they're really focused on, so once that product is developed and designed, they really focus on testing and really understanding the characteristics of those ropes. So these are the guys that work on custom configurations, product selection, helping users understand if you do this with the rope, this is how it's going to behave. They do custom configurations. So it's not just a matter of putting an eye in the end of the rope and using it. There's things that get added onto ropes, tags, lifting straps, so all sorts of strange configurations that those guys work through. And they also, like I said, they really understand how the ropes perform. And we can provide a lot of data and a lot of tools and helpful tips and tricks to really understand what that rope's going to do when you actually put it into use and how it's going to behave in the field. So obviously a big part of product development is the testing. And so, like I said, this is the fun part. So I get to design the ropes, we get them made, and then I get to go break them. And we have pretty extensive tensile testing capabilities. We can test everything from our incoming fibers that are around 20 pounds for those small individual little strands, all the way up to our largest test machine is a little over 1 million pounds. So we've got a video clip here, and is it going to play automatically? Okay. So what you're seeing here, this is kind of our medium-sized test machine. And what you see is a sample of our mercury climbing line. This is a typical brake test that we would do, where we wrap it around capstans. And you can actually see there's quite a bit of elongation in that rope, which is actually a good thing. And I'll show you a little bit later on one of the drop tests that is done on the ropes. So elongation can be good or can be bad, depending on what you're trying to do. But usually in climbing, you want some sort of elongation, because what that is doing, it's absorbing the energy when you fall.
So a little bit of a look behind the curtain. The room we're in right now is one of the larger conference rooms in the Innovation Center where our engineers sit. And it is directly adjacent to our lab, which has the brake test machine that you're looking at right now. Every once in a while, we'll be in the middle of a meeting and we'll hear an enormous loud snap, and that's a brake test being performed, and we all kind of get excited about that. It's a little nerdy, but
that's when the window shakes too.
So again, you guys aren't going to put this much weight onto, oh, there you go, onto mercury to break it, but that's how long it can stretch to.
So tensile testing is probably the most common thing that we do, but we've got other capabilities as well. We do abrasion testing, and again, we do this on the fiber and the rope level. Usually what we're looking for is changes in fibers, changes in coatings. How do they change the rope performance and longevity? We're always looking for longer life. One of the other tests that we do, so in certain applications, ropes are used in continuous bending back and forth over a sheave. And so one interesting thing is that ropes that are constantly bending back and forth like that can actually wear themselves out in a braid from the inside out. And one of the other things that happens too is the strand on strand interactions where they cross over one another actually will start building up frictional heat. And you can see in the picture that the red area in that lower left square, that's the rope actually heating up. So we've actually developed ropes and engineered them specifically for these applications where we use fiber and coating combinations that kind of lubricate the rope from the inside, and they minimize that heat buildup. So not only do they help with the abrasion to make them last longer, but they keep it cooler. And anytime you can keep it cooler, you're improving the lifetime of that rope. Now, this is one that's probably the most relevant for the arborist industry is we do dynamic drop testing. One of the reasons this is done is to make sure the rope doesn't break. But we're also looking to see what's the impact force of that rope. When a mass drops, when a person falls on that rope, how much force does that rope need to absorb? So we've got a couple of videos here. And these are just, again, this is mercury, and there's a European standard that we use for drop testing. And there's a couple different components to it. One of those involves a relatively short drop, and it's looking for what's that impact force, what's that force that's happening on the body, because the body can only take so much. And then there's also basically a series of repeated drops. That rope has to survive five drops without failing, no cover parting, rope can't break. And what's interesting is, so each subsequent time we drop that mass, the rope actually gets stiffer, and not stiffer in terms of feel, but in terms of elongation. So each time you drop it, you kind of take some elasticity out of that rope. And so eventually that rope will fail. You'll wear it out. And obviously the idea is not to fall in the first place, but that's why the rope is there, to catch.
Danielle, what's the weight on this?
So this particular weight is 100 kilograms, about 220 pounds. And so keep in mind, so 220 pounds, when we drop that rope, there's a couple different heights that it obviously depends on what the height is that you're dropping it from. But that 200 pounds translates to roughly 4 or 5 times that. So the rope will actually see roughly 1,100 pounds when you do that drop. So it's not just a matter of a rope catching 200 pounds, it's got to catch about 1,100 pounds or so.
And the break strength on Mercury is about 8,600.
Yep. So the other stuff that we do, so those are kind of some of the standard tests, but we also get into custom tests. So we've got a wet chemistry lab where we're evaluating coatings and formulations before we even put them on the rope. Some of the ropes are used in pretty high temperature applications. So we've built, basically it's a rope oven that's installed kind of in the test frame, in the test machine, just to kind of understand the rope, how it behaves under high temperature environments, and not just room temperature. Now this is a fun one. During product development for a replacement for an emergency tow-off line that's used in case of a fire on a shipping terminal, we were kind of asked, well, how does the rope behave under high temperatures as well as actually under flame? So we basically put the rope into the same test chamber that's used for testing firefighter gear. We had some fun with this one. So like I said, I get the fun job.
We recently had a request too about rope used in highly radioactive environments. I do not think we'll be performing
I won't
those
be
tests.
playing in that one. Now, sometimes you can't take the rope to the field, so we bring the field to the test lab. We've brought ship's chocks and installed them in the test machine. And this test, we're testing abrasion characteristics and how does chafe material perform when running through the chalk. We also bring trees and we put them in the test machine. And here we were testing hitches and knots and kind of understanding. So it's all great and fine and dandy to test the breaking strength of that rope in a lab environment. But when you actually put it into use, and depending on how you configure it, that strength completely changes. So really understanding that becomes important. So at the end of the day, after all the product development and the rigorous testing that we go through, we've received several certifications on the products. These cover a variety of applications and industries, and our company as a whole is also ISO 9001 certified as a quality system. And with that, I think Gavin's going to talk about some of the new products which are CE certified.
Thanks, Danielle. Good stuff. Yeah, we actually do have quite a few products coming out in this fall and early next year, and a lot of the projects that actually Danielle helped me work on too. Of course, the wrong one. The first couple I want to show you are our V16 and our V24 ropes. Basically, they're upgrades to our previous 16-strand climbing lines and our double braids. The task I gave the engineers when I first briefed this product was to see how the core and the cover could work better together. Previously, they were definitely designed very, very well, but in an effort to improve strength, reduce milking, and improve overall efficiency, this was the top guide given. So first of all, the V16. It is an upgrade to our Arbormaster climbing line, really good for locking hardware and climbing hardware, perfect for all climbing techniques. The construction is polyester nylon, with a 16-strand and a small nylon core to keep it from flattening out. It is CE EN 1891 Type A certified. It's a half-inch. Average breaking strength is 8,100 pounds, and weight for 100 feet is 7.4 pounds. And it comes in two colors, hot and cool, similar to some of our others. There's the hot one, and there's the cool one. So moving on to the V24, which is also EN 1891 certified. What we changed about this one, again, improving the relationship between the cover and the core, is we, instead of having each diameter named something different, like some of our products we've had in the past, this one is offered in 3 diameters, an 11 mil, a 12 mil, and a 13 mil. And again, a polyester nylon double braid, a little of a look behind the curtain on the colors too. What we wanted to do to give it a little bit of a pattern, the 11 millimeter colors, we wanted to give essence and influences that were from the ground. And that's the hot. So they look like dirt and different types of soil. For the 12 millimeter, we wanted to have influences from trees. So we've got green and we've got some grays and green. That's the 12 mil. And for 13 mil, we wanted to look like sky. So we had a deep navy and a light blue. Feedback from the field has been fantastic so far. We're really, really excited about this. It should be available to order pretty soon from Tree Stuff. Arbor Master, the exciting thing here is that we've added a new diameter, an 11.5 millimeter. This is specifically around tree clearance and certifications that are required to have it be inspectable through certain hardware. So this has been something that's been requested from the field. And similar to our other Arbor Master colors, where instead of giving hot and cold, we gave them names. This one is Supersonic. And this one is Wildcat. Next, something we're really excited about, something we've been working on for a little while, and it's come out really nicely. A 100% polyester static kern mantle product that has crossovers into arborist as well as rescue and access. Available in 11.3, 11.7, and 12.5. Again, the feedback from the field has been excellent here, and we've sent it up for testing up in BC. We've done testing down in Seattle. So here's the 11.3 mil, the 11.7, and the 12.5. And these are UL certified as well, NFPA. And you guys are probably all familiar with Mercury, our 11 millimeter kern mantle. This is already also now EN 1891 Type A certified. And then probably the last thing, a little bit of a preview coming in 2022, we're going to be developing and offering an online training program. We'll be calling it Classroom. That's places where you can learn more about basic construction of ropes, care for ropes, inspection, retirement criteria, splicing, et cetera, et cetera, et cetera. You can use this either individually or run it through your own company. And we are looking to make sure that it is available to have credits from some of the other organizations that you all work with, and we'll announce that closer to the time. Moving on to some of the resources we have available on samsonrope.com. Whenever you go to the homepage, you can click under resources, and there's lots of information around case studies, catalogs, et cetera, et cetera. In particular, lots of resources on how to splice rope, 3-strand, 12-strand, 16-strand, and double braids. So make sure you go to samsonrope.com for all that information. There's also arborist catalogs to take a look at, and rope users manuals. So just take a look at everything, and of course all the product information is there. Yeah, that is most of it, and that's pretty much everything we've got for today. Kale, are there any questions that have come through for us?
Yes, I do have a couple of questions here. The first one is about using ropes after drops, watching the drop testing. If the rope still looks good, is there a certain number of drops that you still should retire the rope on?
Yeah, there's no magic number as far as number of drops or number of times you fall on it. Honestly, I would say if you've fallen on the rope, because you can't inspect, you can't tell if that rope is damaged or not. You know, from the outside, it probably look just fine. Mm-hmm. But if it's experienced a shock load or a drop, I would recommend retiring it. And personally, I mean, you're hanging from that line, so it's really not worth it.
Okay. Another one here, probably, which would be a great one for you. I don't know how much you know about the different tools that arborists use, but one is a porter wrap that involves. Sorry, excuse my child is in the other room banging some of his toys together. When you're running a rope around a porter wrap, how do you keep the inner and outer parts of the rope from separating from each other? How do they stay together, I guess?
I guess the first part is just to make sure the end is sealed. When you first start using that rope, we typically heat seal. You can kind of melt the core and the cover together. So as long as those ends are sealed, they shouldn't really be separating. Usually, if that seal becomes broken, and then the covers and the cores are they're a little bit more free to move independent of one another. So I'd say that's probably the best way, is just heat sealing. Heat seal, tight tape wrap on the end. There's nothing too fancy required there.
Okay, gotcha. This one's probably more for Gavin, asking about the construction of the hyperstatic, what the sheath and core materials are.
Right. I did notice the presentation said polyester nylon. It is 100% polyester. So the core and cover are polyester.
Okay. And is that a 48 strand?
No, it's 32.
It's a 32. Shane was asking if you guys have a 48 strand.
We do not have a 48 strand.
Well,
You're going to get a 48 strand?
We're going to buy a braider, huh?
Yeah.
No, it's 48 strands are pretty common for more dynamic mountain climbing ropes. I mean, they're certainly used in the arbiter industry too.
Mhm.
But Samson, we don't actually currently have 48 strand braiding capabilities. So it's 32s.
Okay. All right. How can you talk a little bit about the construction of a kern mantle rope and what the difference is between that and your regular double braids?
Yeah, absolutely. So of course, double braided, as per the name, has a braided core with a braided jacket. The kern mantles technically have parallel cores. That doesn't necessarily mean they line up exactly next to each other like this, but they will at least occasionally wrap around themselves and intertwine. But they are, by definition, parallel cores.
Okay, and is that giving you? I guess what's the feature then?
The benefit there is it has less elasticity and greater strength.
Okay,
Anything
great.
else you would like to add? Yeah.
Let me see if it doesn't look like I have any other questions right now for you guys. And if you have anything else to say, or you'd like
Probably
to
the
plug.
last thing I'll mention is that back in the Tree Stuff archives, there was a lab and factory tour that should still be there that these guys did with us early 2019.
Mm-hmm.
So feel free to check that out. Lots of good information. Yeah, I mean, it was a good day of filming. So yeah, take a look at that. And I think that's probably about it.
Okay, one last question that popped up in here. Is there an age for ropes where you need to retire them?
Yeah, there's no specific age. It always depends on the environment, its treatment, the usage, how many drops, et cetera, et cetera. So I would not put an age on retiring a rope specifically.
Gotcha. Great. All right. Well, thank you very much for taking the time to do this for us. And I hope you have a nice day.
Yeah, thank you. Thanks to everybody at Tree Stuff. This is great.